You pop a bowl of leftovers into the microwave, press a button, and within seconds, your food is hot and ready. No flames, no boiling water, no hot metal coils. Just invisible waves doing all the work. But what's really happening inside that little box? How does a microwave oven cook food so quickly? The answer lies in a type of energy called microwaves, a form of electromagnetic radiation, just like radio waves, infrared, and visible light. But unlike sunlight or fire, microwaves don't heat the air or the container first, they go straight for the molecules inside the food. Here's how it works. Inside the microwave oven is a device called a magnetron. When you turn on the oven, the magnetron generates microwaves at a specific frequency, about 2.45 GHz. This frequency is just right to affect water molecules, which are present in almost all foods. Water molecules are tiny dipoles, meaning they have a positive and a negative end. When exposed to microwaves, these molecules start to vibrate rapidly, rotating back and forth millions of times per second. This rapid movement causes friction between molecules, and that friction produces heat. So instead of heating your food from the outside in, like a traditional oven does, a microwave oven heats the food from the inside out, wherever the water molecules are concentrated. That's why microwaves cook food so quickly and often so unevenly, because different parts of your food may contain different amounts of water. Let's take a real-life example, reheating a slice of pizza. The cheese may melt and bubble quickly because it has more moisture, while the crust might stay cooler and chewy. Or heating up rice might make the center hot, but the edges remain cold, because microwaves don't penetrate too deeply, usually only about 1 to 1.5 inches into the food. The rest of the heating happens by conduction, heat spreading from warmer areas to cooler ones. Right pointing finger emoji. If this breakdown helped you understand what's really happening inside your microwave, hit like and don't forget to subscribe for more everyday science explained simply. Now, let's look at why this is important to know. Understanding how microwaves work helps us use them more effectively and safely. For instance, metal reflects microwaves, which can cause sparks or even fires. That's why you should never put metal utensils, foil, or even some decorated plates in a microwave. On the other hand, microwave-safe containers are specially designed to let waves pass through safely. Knowing that microwaves heat water molecules also helps explain why dry food doesn't heat well, and why you sometimes need to add a little moisture, like a splash of water when reheating rice or pasta. In terms of applications, microwaves aren't just used in your kitchen. The same science powers radar systems, satellite communication, and even medical treatments like diathermy, where microwaves are used to generate internal body heat for therapeutic purposes. Microwave ovens have transformed how we live. From cooking in dorm rooms to defrosting meat in minutes or steaming vegetables without a stove, they save time, energy, and effort. They also help reduce food waste by making leftovers quick and easy to reheat. In schools and science classes, microwave ovens are a fun way to teach concepts like wave energy, molecular motion, and thermal conduction, all in a machine that almost every student has seen at home. So next time you hear that soft hum from your microwave, remember, it's not just warming food, it's exciting molecules, generating friction, and turning invisible waves into delicious heat in just seconds. It's everyday science in your kitchen, working faster than fire ever could.